So in the first video we talked about learning form, we're learning to paint in the 3 dimension, and also how to practice composition as well as practicing the form, and that took the form of these little form studies that we did, just using shapes instead of lines, and then for more of the composition and more of the detailed form, these kind of very low detail, very pixelated studies that can then be upscaled to fill in more detail at the artist's whim. And we also talked about how I recommend to kind of start out trying to use very simple reference of still lifes, of basic shapes, and then moving into maybe more complicated little items, kettles and bottles and just basic kind of still life stuff. That's the easiest things to paint. And then in the second video we talked about how to shade, and that was everything to do with shading, and that really is, once you have that 3D comprehension from the first video, that second video is really talking about the bulk of what it takes to render for anybody that's interested in moving to that level. This is kind of the third level and the final of the most important demos from me, and this is going to be just cleaning up a little bit of a few tidbits. This is going to be lighting. We're not going to look at everything to do with lighting because most of it comes down to your 3D comprehension and also how you simulate things in your head, which is what we're going to talk about. So there's not really much that's really worth teaching in lighting, because by the time you're at that level of competence, you're going to figure out a lot of this stuff on your own, just using the logic in your brain, right? But there's still a few little things that I want to clear up, very common things and things that kind of beginners might run into before they're really fully familiar with stuff. So let's get into it. So the first thing I want to talk about is last time I talked about how we have shading and lighting, and how lighting is actually a simulation, right? And the shading was purely like a geometric thing, but the lighting is actually a simulation. And I used a couple of words as well. So there's 3 types of kind of ideas that I have in my head for how I simulate things, and all of them are kind of a generalization. But what I mentioned as well is what we're really doing is the job of a computer. So when you use a piece of software like Blender, what that piece of software is letting you do is first, model a cube, and create a scene that might have a light in it. And then what the computer's going to do, and a camera, sorry. What the computer's going to do is, it's when you click render, it's going to, I'm doing this backwards, it does it from the camera to the light source, but the way we do it in our heads is a little bit more intuitive. It's going to send rays out from the light source, loads of them randomly, depending on the settings that you've chose, and those rays are going to bounce off of things. So basically they're just simulating photons, and the ones that go into the camera, those are going to influence those are going to land on the virtual sensor of the camera and influence that particular pixel that ray lands on. So it's kind of simple in principle, but it's one of those where it's many little simple things to make one larger complicated thing. And that's obviously quite difficult to do in your head. Well, I mean, you just couldn't simulate something like that in your head. But what we can do is generalize. So when we're actually thinking in our brain, we're thinking this exact same thing, and we're just kind of generalizing the rays, right? And it all comes down to how you imagine it in your head. So, like I said, there's 3 ways that I tend to imagine these principles in my head. And the first one is the rays, like I just said. So that's just literally, the rays, shooting out of the light source, hitting off of stuff and going into the camera. That's probably the least intuitive but most accurate way to think of it. The second way that I like to think of it is kind of in between there. It's ping pong balls, right? So what I like to imagine is that this light source is throwing, instead of rays, it's throwing ping pong balls out everywhere. And those ping pong balls are bouncing off the scene, and just kind of going everywhere. And they're not just bouncing, but every time a ping pong ball bounces off of a surface, the ping pong ball... so let me explain. When the ping pong ball comes out of the light source, the light has a certain colour, right? So it might be yellow. And it has the same sort of values that you might pick for a paint stroke. So it still has hue, saturation, and brightness. And the ping pong ball actually inherits the properties of the light source, right? So we've got a yellow ping pong ball. If the ping pong ball bounces against something that is, let's say it's a red surface, that ping pong ball will actually inherit the properties of the surface. And we'll talk about this more later. But every time those ping pong balls bounce off of a surface, they can actually inherit those properties. So that ping pong ball will become orange. That's yellow plus red makes orange, right? And then when it falls onto the sensor of the camera and hits into it, right, the pixel that part of the sensor is assigned to will display orange. So that's simple enough. Okay, and like I said, we'll go into that a little bit more later, but that's the basic principle of it. The third way that I like to imagine light sources is volumetrically. So this is quite this is quite difficult for a beginner, but once you have a really natural feeling of a really natural three-dimensional comprehension and understanding, it becomes much easier. So if we imagine our light source, we imagine kind of like, like a bubble around it with soft edges, of course. And anything that's in that bubble is going to get slightly tainted by it, right? So that's going to kind of be it. And if something's kind of in the bubble here and it's absorbing that light from that bubble, it will actually change the shape of the bubble. So I hope that kind of makes sense in an intuitive way. And that one is really intuitive, and I very much think of light in that way, that kind of volumetric way. And that'll work really well for kind of bounce light, which we'll talk about later. So, if you have like a surface here, and obviously there's light shining onto it, there's a thing called bounce light, where the light will be bouncing back off the surface, like we was talking about with the ping pong balls. So if you imagine that as kind of a radiance, you can imagine that item becoming like a secondary light source and shining its own bubble of radiance out, right? And then anything else, any other items in that radiance are obviously going to pick it up, modify the shape of it a little bit, and then send their own radiance out. So that's kind of the three ways that I like to think of lighting. And like I said, this is going to be a lot of little tidbits, so I'm just kind of going through one after the other. Hi, it's Post-Processing Lewis here, and I'm here to add a little bit to the episode. I knew I'd forgotten something at the end, and this was it. So let me have a new layer. And I've literally just recorded this a few minutes ago, so just adding this in. And this is more about how the light inherits. We was talking about how the light will inherit the colors that it bounces off. I didn't talk about how that works practically, and the most common one that people kind of deal with under that range is skin tone. So let's say we've got this is the pen tool. So let's say we've got a ball that is skin tone, and skin is orange. This is a bit too orange, but it doesn't matter. When we have some light, and the light, let's just do the actual light source itself, like the actual value of the light source. It will appear white to the camera, but I'm turning up the exposure loads to kind of help. Okay, so we've got our light source and we've got our skin tone. And like I was saying, when the light hits off of the skin, it's going to kind of inherit some of that. So what you can actually do to light things is grab the default light color, and you can actually, I don't always recommend this because it won't give you like very nice looking tones, but you can do this. You can actually just glaze the light source and I do this all the time. If you watch me paint when I'm streaming or whatever, you'll see I constantly do that. You can actually just glaze the value of the light source onto whatever you're lighting, and that will work, because like I said, it's a mixture, right? So you're kind of mixing the light source and the local value of the object. And I'm thinking of that radius still that we was talking about a second ago. So you've got to think the radius of this light is kind of like hitting the ball of skin tone that we've made. All right, but this is where I'm going to start talking about the really practical aspect of it. You'll notice that if I color pick this here, you see that it's not very saturated on our color picker, right? It's basically like the light source. The light source is so bright that it has to be desaturated, because white has no you can't get a saturated white, right? If I try and get saturated white, oh, it's not as bright anymore, right? This yellow color, it's not as bright because it's got some saturation. So you have to sacrifice some of that brightness for the saturation, which lights won't really do very much. They will, but they won't really. Not the sun. The sun is quite desaturated. It's just very light yellow. It's pretty much what we picked here. Okay, so, but if we color pick the ball, we'll notice that it's way more saturated, right? So we're thinking about how that's gonna, when we're painting, we'll often want to be, painting in a way where we kind of tile. Tiling is a very common way that I like to paint. And when I'm doing that, I'm trying to use this color picker to pick the actual colors that I'm thinking of and directly put them on the canvas, which can be quite difficult if you don't understand the rules, okay? So all of this is just me explaining that, especially with skin tone, if your local value is quite saturated and your light is quite low saturated, when the light bounces off of your local value, it will actually come back and desaturate that. Okay, so what you're going to get is, and I spoke about this in a previous one, you're going to get this diagonal look. As something gets brighter, it's going to get less saturated, and as it's darker, it's going to get more saturated until it reaches the saturation of the local value, and then it will start going just down straight to dark. And what you're going to get really is this curve, this exponential curve, right? It's going to be like that shape across your color picker. Does that make sense? And it's going to curve down, and you're going to get that in a lot of items. So if I want to figure out what the value of the bottom of this should be, where it starts getting dark, we can follow that curve down. And the light source was more yellow, right? So in a similar way, and in the same curve, if you were to plot it on a graph, it's going to get more towards what the skin tone might be. So it's going to get it's basically going to get further away from this yellow light. And on skin tone, you can actually go all the way to purple if you like. And that normally looks pretty organic still. And that's, you can actually get more saturated than the local value should be as you get darker, because if you notice, very saturated black is still black, right? It's the opposite to white, where saturation will affect it. Black overrides any saturation. And so you can actually, and you will in real life actually, see that things get more saturated than even the local value as they get darker. I don't know the full reason for it, but it looks right, and it's just kind of how it works a lot of the time. So what we've done is we've followed that curve, and like I said, the light is more yellow, so we're going to get less yellow even. It's just going to get pushed away from that. Yeah, literally, if you think of that yellow band as where the light is, we are actually pushing the color picker away from that as it gets darker. And in that way, we can predict, I've done it exaggerated for us, but if I pick it a little less strong, we can kind of predict what the bottom of this ball should look like where there's less light. Okay, and you see it, even though it's more saturated, it doesn't look as saturated because of the way, like I said, dark, black is black, whether it's saturated black or unsaturated black. And you're going to find that the most saturated place where you can see the color the most is really going to be in these middle areas. So you can see the curve for this really looks a lot like that. So in this middle area here is where we're going to get to sneak in kind of the most actual visible saturation, where it's not overexposed and it's not too dark, okay? And you'll see that that is actually shaping up to be, while I did pick a very orange skin tone, it is skin tone, right? And then, you know, we're talking about reflections later, just after this little bit, actually. But, you know, then your, you know, specular reflection is going to be on there or whatever's going on. So I just wanted to explain that. And it's the same in the reverse. If you've got a grey ball and you've got a very saturated light source, say your light source looks like this instead, that grey ball where the light source is hitting it is going to be, it's going to look green, right? It's going to become, it's going to inherit the ping pong balls that have the letter G written on them. It's going to, those ping pong balls are going to hit up of that surface and they're going to remain pretty green, right? They're going to make it more saturated on the surface of that grey ball that I'm imagining but haven't quite drawn. Okay, so things are, if the light source is more saturated than the local value, it's going to make the local value look more saturated. And if the light is less saturated than the local value, it's going to make it look less saturated. And when that grey ball gets darker again, if it's very slightly green, it's not quite grey, it might find its way to become just a little bit more saturated in those darker areas. All right, so that's pretty much that. The other thing that you might see often is on our skin tone. So the sun, we had the sun color there, but we might also have, and we talked about this in a previous episode, a skybox. And the skybox might be bright blue light, right? If you look up at the sky, it's very bright blue, quite saturated. Blue and orange are opposites, right? So the negative of blue is orange and the negative of orange is blue. So what you're going to get is they're going to mix together and you're going to get grey, right? They're going to desaturate each other once they mix. So we're going to get our orange and we're going to mix that with blue. So it's going to kind of come towards the blue, but what's really going to happen is it's going to become way less saturated, right? It's going to come pretty much towards grey, and a lot of people will say it gets colder. So I can now draw the effect that the sky, and again, I can just glaze this on because now I've got kind of the right value that I'm looking at. I can sort of draw the effect of the sky onto this skin tone ball, right, as more grey. And you'll see that should actually look pretty convincing even in this pretty quick, crude demonstration. So you see now it looks like that is more, it looks even more like that is outdoors. And as it gets more towards the edge, and again, you can literally just copy what the light value is. You could literally just select the sky itself. It's just going to become, it might go from being grey to actually having a literal blue tinge on it. So you can see it goes light, and if you watch my color picker, watch the dynamics that happen. Okay, so you see that line? You see how it's drawing this graph that I showed you earlier on the color picker? Okay, and then if we go from the center outwards, you see it will get grey. Oh, you see it's losing saturation as it's mixing that orange and blue together. And then it might turn blue, or, you know, close to it. It's actually quite green. You can see more blue here. And it might actually start to get more saturated again, just in the blue side of things. You see it goes from orange, right? And it gets less saturated as we go towards the edge. It's really saturated there. Gets less and less saturated as the orange and blue mix. Okay? And then the color picker goes to blue, and it gets even a little bit more saturated. Okay, so that's my little interjection. That's the one thing that I forgot. I'll let the video continue from here. So the next thing that we have to talk about here, I wanted to talk about reflections specifically. We already just talked about them a little bit with the ping pong ball analogy, but there's a few little things to do with reflections that I want to kind of just clear up and make easier for people that won't already know, just so you can kind of dive in and just immediately, get painting or drawing or whatever. So, with reflections, as we just mentioned, there is bounced light. So, the way I like to think of bounced light is as a secondary light source, because that's kind of what it is. So, if I have a ball there, we can imagine the radiance, all the ping pong balls, all the rays, however you want to imagine it. When the light hits this side of the ball, so the light hits this side of the ball. I've tried to make that side dark for you guys. So that side's in darkness, that side's in light. What you can imagine is that this side of the ball, this hemisphere, actually becomes its own light source, right? Okay, and that's always going to be darker than the original light source because some energy is lost, and it's always going to be the ping pong balls that come out of that light source are going to inherit, whatever colours were on the light source, like we was just talking. So blue and yellow. Blue and yellow kind of make grey, so it's just going to become kind of like white light. It's going to lose saturation. And that's another thing as well. Things will mix together exactly how kind of, not how paint mixes together, but how light mixes together, and there is a difference there. So basically, if you're mixing blue and yellow, you're going to get grey, which is going to be more like white light, basically. And those are going to be, that's going to be the colour of the radiance coming out from that item. And I really like to think of it as radiance often with bounced light. I think of the ping pong balls in order to get a feel for what properties, for what value the light might have after it's bounced. And I like to think of the radiance to think of what shape it might have. The radiance is also good to think about fall off, because obviously this radiance, like I said, it's a very soft edge, and that is to represent the fall off of the light. Anything out here is going to be outside of the radiance, so it's only going to be affected a tiny bit maybe by that soft edge. Okay, so, and just to explain, that is going to be where you're going to see that sort of stuff is where you've got the same analogy we was using earlier in the last episode, where we've got a ball on a plane. That bounce light is going to be bouncing off the plane and hitting the ball underneath, right? And that's why you get kind of a darker band here on the ball and here. But in this middle section, here, if I try to highlight it for you guys, that's where it's going to be a little bit brighter just from the light, bouncing off of that plane that the ball is sitting on and hitting the ball itself due to that secondary light. All of this ball is in that radiance, and like I said, the ball being there will actually change the shape of the radiance, and that's why if I put something up here, it's only going to be affected a little bit. If I put something here, it's not going to see any of the light that's radiating from that plane. It's only going to see the light from that main light source. Okay, so hopefully that explains bounce light. The next one is pin light, and there's something that I'll probably explain in another episode, but I'll just mention it quickly now. The difference between there's something so we talked about shading last episode, and shading, just by happenstance, tends to look very much like matte materials, right? There's just no glossiness or shininess. That's what shading looks like. That's why the thumbnail was like a statue, because the statues are very matte and don't have many reflections on them, so they already just look like they've been shaded but not lit. Okay? And the difference between something that is matte and something that is shiny is purely in the image that we see on the ball. So if I have my light source here, right, this side of the ball is all going to be lit up, right? And it's very blurry, right? Like literally, it's quite blurry on a matte surface. It's very it's very soft edges and such. And the shinier the ball gets, this is really important now. The shinier the ball gets, the less blurry that shape of light becomes, right? And I hope people are starting to understand that, until it becomes an image, right? And then we might get an actual image And it's not just in the lights, but we might get an actual image of, say, the table that the ball is sitting on, anything that's on the table, right? And that's kind of what it is. But as the ball becomes more matte, it's still reflecting the table, but it's become so soft and so blurry that you can't make out the table anymore. And that's kind of how this radiance ends up working, okay? So that is a really important thing. And I'm just going to gloss over that quite quickly now, because I might go into that in more detail later or in a short or something. But it's kind of like, it's easier to see if you go into like something like Blender and have a look at the slider, where you can slide something between matte and shiny. And you can actually see how a matte material is exactly the same as a shiny material, but it's like a Gaussian blur filter has been applied to it. Right. Now we're going to look at pin lights, okay? So let me explain something else. This light source is really bright and the table is not as bright. So if we have a ball that is kind of halfway between matte and halfway between shiny, so like I said, you can still see like the table and stuff like that. Anything that is really bright and really sharp, it might cut through that. It might be so bright and so sharp on this kind of half shiny, half glossy material that you'll still see, you know, it won't blur it enough to not see the light anymore. And that's when you get what's called a specular reflection, a pin light, or a highlight. Those are all synonymous, means the same thing. And that's why you'll get that kind of sharp reflection of the light here. That's all it is. That's why the highlights pop out so much more than anything else. Okay? All right. Now, that's the why. We've got the why out of the way. Now let's generalize things. The most difficult thing that I've noticed beginners struggle with is where to place the pin light. Obviously, as a lot of people have seen before, the pin light will often take the shape. I mean, of course it will, because like I say, it's just a type of reflection. Excuse me. And also bear in mind that the pin light will still be Gaussian blurred, depending on the amount that the surface is polished, right? So it's bound to take the shape of the light source here. But what we was talking about, sorry, let me not get sidetracked, is let's just pretend that's one light source. Is how to place the pin light. So let me get rid of that. Let me get back to here. Okay, so let's say we've got a light source and a ball, and our ball is kind of half reflective like before, like we was talking. So what's going to happen is we're first going to shade our ball. So like I was saying earlier, you're going to have the shadow, you're going to have the halftone leading down to the shadow due to the angle of the ball, and also the light fall off, which is less of an effect. But then what you're going to have is, like I said, this is so bright and sharp, it's going to cut through this kind of Gaussian blur effect. Right, so where do you place that? Okay, so the light is hitting the ball in a very specific spot, like for like, if that makes sense. There's always going to be like a center point where the light is hitting the ball. And for our example, we're doing the same example as last episode. It's going to be right on top of the ball, literally. And this is just the shortest tangent between the light source and the ball in the case when it's a ball. Obviously, you'll have different shapes and you'll have to figure it out for different shapes individually. But it's going to be right here, okay? And then we've got to think about the camera. So the camera is looking dead at the ball, and this is going to be the exact same point as the light source. It's just, you know, every camera has like a center of vision, okay? So if you imagine your camera, okay? You can imagine that your camera is shining a laser out, okay? And that is your center of vision, and it's always going to land on the horizon. And we want to think, where is that center of vision hitting the ball. Okay? So for our example, it's very simple. It's going to be hitting the ball right there, right in the middle. Okay? So that's where the camera's hitting the ball. That's kind of the center point of the camera hitting the ball. And that's the center point of the light hitting the ball. The pin light for a ball, and remember it's going to be different for different items. The pin light is going to be somewhere in between these 2 points. Now, where you want to put it in between those 2 points is up to you. On a sphere, it's going to be dead in the middle. But if I squished my sphere down, it's going to get pulled. Now, what happens as well, this is something else I want to talk about. Reflections get pulled towards horizons. So what is a horizon? That's basically where the camera is seeing a surface, at a very, very slanted. And the more slanted it is, the more of a horizon it is, okay? So where the camera's looking dead on at the ball is not a horizon, that's dead on. A bit more of a horizon, a bit more of a horizon, that's a massive horizon. So you're seeing a massive horizon on that ball, right? It's very slanted on the edges. And the reflections are going to get pulled towards that. So if we squish our ball, you've got to think this becomes more of a dramatic horizon. It's more aligned with the camera. You're looking at more of the surface at once. That, like we said before, that's where the light is hitting the ball. That's where the camera's center of vision is hitting the ball. Or not quite the center. Yeah, if the camera, it's not always the center of vision of the camera. It really is similar to the light source, where it's like the closest part of the camera to the ball. But in this case, the camera is looking at the ball, so that is going to be where it is. If we squeeze that ball so there's more of a horizon there, it's going to pull that reflection up and squeeze it. And it's going to do that to all the reflections, so the table is also going to get pulled into that horizon. You can imagine that each of these horizons have like gravity, okay? And the stronger that horizon is, the more gravity it's got. Now, the next thing I want to explain to you guys as well is how the blurriness can work with horizons as well. This is also this principle will really make your artwork pop and look amazing. Just think, things are going to be sharper on the horizons. So this light, where it's been squeezed here, because it's been squeezed down as well and it's on a horizon, same with the table, where things have been squeezed on these horizons, they're going to be sharper. So if you paint a perfect reflection on this ball, and then you want to make that reflection look more realistic, what you can do is use your blur brush to blur the middle of it. And let me show you that in painting form, because that might actually help. So we've got our ball, and it's sat on the table, and black just was the color of the brush, so that's what we're using right now. Let's say it's a brown table, why not? Make it a little bit brighter for people watching this on mobile phone or what have you. So we've got a bright table. And our ball is sitting on the table, right? It's going to be reflecting that table, and it's going to be slightly darker because remember, when light bounces off of stuff, it loses a little bit of that energy. The ping pong ball bounces off of that thing, and the values change a little bit. And one of those values that changes is the brightness. It's going to get slightly darker. So we're reflecting the table here. Let's just say that everything around the table is quite bright, like the ball is in a white room. Or let's not make it so bright, because we still want to put the highlight on there. But I want to differentiate it from the background, so a little bit brighter. Okay. So yeah, say the ball is in quite a bright room. It's looking at the table, and remember the table's going to get pulled into that horizon, that reflection of that table. And then we're going to get the light bulb in the ceiling. Okay? And if there's anything on the table, let me just make it a little bit even more advanced. So, or just put a little bit more detail in there. If there's like a ball, another ball on the table here. Okay? we're going to see that ball in the reflection. All right. So you see already that looks like a reflective ball. It doesn't look amazing, but it looks pretty close. And remember I said that's going to be blurred a slight amount. The ball isn't perfectly reflective. And everything is also going to be slightly blurred. All right. So there you go. That's our reflective ball. What I was trying to explain a second ago is things are going to be more blurry where the horizon isn't. So if I blur the light there, you see this top part of the light source is closer to the horizon, where this bottom part of the light source reflection is further from that horizon and it's more straight on with the camera. That's going to get blurred a little bit more differentially, and you're going to still see that sharp edge here, but you're not going to see it on this side of the light. Similarly, the table's going to get blurrier as it gets more towards the middle of the ball, okay? And that's how you're going to make your reflections look more realistic. And this is something that I only learned recently. And you've got to think as well, these horizons, and this is part of the reason why, these horizons are catching more things because of the way that they are like gravity and sucking everything into them. So any other light sources in the room and pin lights, they're very often going to get sucked to that outside, layer of the ball, okay? And they're going to look sharper there, right? So these ones that I did more in the middle of the ball, we can blur these a little bit more. And you see that you start to get something that does look very convincing. Okay? So that's just my quick explanation of how pin lights work, how to place them, and how blurry they should be, and how blurry they should be in each area of a reflection, okay? And also how things should kind of be warped on a reflective surface. So that was a lot of information, but I hope that was kind of useful, okay? I did also mention this camera's center point over here earlier. I need to think about that a little bit more. I'm not sure if that's quite accurate. I don't know if that matters as much as just the shortest tangent between the camera and the ball. I don't know if it really has much to do with the actual center of vision, but that center of vision is a thing, and we'll probably talk about that in future. I like to call it a center of distortion, because, if you've got a fisheye lens, that's going to be the middle of the fisheye lens where there's no distortion, and as you get further away from that center point, similar to a reflection like this, it's going to get more and more squeezed. You can think of a reflective ball as something that looks a lot like a fisheye lens. It's kind of the same thing, really. It's just reflection instead of refraction. So that's a little bonus for you guys. All right then, that's bounce light and pin light and color dynamics. We've talked about reflections. I think that might be everything covered. We already kind of mentioned bounce light. I think that's pretty much everything to do with lighting. There's obviously also translucency. There's not much for me to really explain there. It's things that are see-through. It's going to be exactly the same kind of warping as reflective stuff, like I just alluded to. So wherever there's kind of a horizon, things are going to get kind of magnetized towards that and warped towards that, like gravity. Also, remember that you can't just make things opaque and on an opaque layer, because you won't have the thickness. So obviously something that's translucent, the thicker it is, if it's a piece of green glass or whatever, the thicker that glass that you're looking through, the more it's going to make what you're looking at behind it look green, right? So there's stuff like that, but most of that is kind of pretty easy to figure out, especially once you've already got reflections down. And also you think about the ping pong balls when you're thinking about translucent objects. I showed the ping pong balls bouncing off of the surfaces here, but obviously if it's a translucent object and you've got your light source throwing out all these ping pong balls, the ping pong balls are actually going to, well, one, they're going to be bent at the surface slightly, but they're actually going to travel through the object, right? And as they travel through, and the longer that they travel through, the more they're going to pick up that value of the ball, and also kind of the darker they're going to get, because they're kind of getting sapped on energy as they go through the green glass ball that we've got here. Yeah, I think that's everything. This one's a very short one. Like I said, it's just a few tidbits for me to clear up and explain, sort of how lighting works, because we've already gone through shading. Like I said before, shading is going to do the bulk of your work, but lighting is going to make things have that extra level of believability. So I hope that's helpful to some, and I'm going to sign out. Bye bye, and see you next time.